All right. Good evening, everyone. Wanted to jump on real quick this evening to discuss some ideas about system design and use today's charts to go over some of those principles. We're going to try to keep it quick today and uh, maybe around 10-15 minutes. It'll just be myself and Brad will be joining me likely for the next one. So let's jump into it as normal, as usual. Just anyone with comments, drop them in the chat, and we'll go over them as we're reviewing the chart. So let me share my screen here. All right. So what I wanted to, or where I thought it would be useful to start, is actually with some teaching tool that I just built and still in testing, but we can use it to demonstrate the principle. Basically, what it does is it shows the importance of, or helps kind of internalize the importance of the secondary filters that you use to value your signal generator. So all systems are designed around a signal generator that provides the initial uh, decision of whether to uh, begin taking a trade, you know, assessing the entry mechanisms, or waiting, or doing nothing. Um, so the here, as you see, there are some stats here. These are based on the breakout code that a lot of the students in Systems Academy use when they are designing their systems, and it generates a number of different signals based on different types of breakouts. And so what I've done is just go into the code and added a module. I can open it up here. It's a module at the end of the code. That's all the stop and entry information. But basically, what it does, this is a backtesting module, and it's very rudimentary. But from here, so the code is up to about 600 lines of code, and this is 600 more lines of code. So it's not inconsequential, but as far as actual signal generation and execution, it's not that heavy. So the idea here is that the user can go in, the student can go in and select the signal. And so here you can see the first signal number 1 is breakout and follow through. 2 is big breakout and follow through. 3 is climax and follow through. 4 is outside bar and follow through. 5 is a big breakout bar without follow through. 6 is a climax bar without follow through. And 7 is just a regular breakout bar without follow through. And one of the first things that we can see is that if you change the pullback depth, so even if we kind of zero out all of these other have rudimentary conditions here, if we take off the bar since entry and since signal, we'll even turn these off. Okay. So the reason I started working on this is because of the importance of pullbacks, and I'm sure a lot of you know and understand that already. But when thinking about how to weigh a signal and whether it is what type of entry it demands, the first thing to consider is obviously whether it's a buy the close, sell the close, or if it's a signal that is likely to get a pullback before getting follow through. If it's a signal that is for trend resumption. So immediately, if you start looking at, say, 1% of pullback, your R value goes down immediately, substantially. Just waiting for a pullback of 50% brings that down to, I mean, it's still a negative setup without any optimization. So if you're just entering at 55 to 60% pullback of the setup, um, even 60% gets funky. So just waiting for a pullback is much better than buying the close and selling the close in most cases. And there are certain probabilities of whether most trades will get immediate follow through or pull back first. And this was initially conceived, I thought of it in order to highlight that foundational principle of assessing signals that your system generates. If we go to the big breakout and follow through, or sorry, just the big breakout without follow through, you can see that waiting for a pullback of 55% of the signal. So in this case, this was a bear signal bar here, waiting for 55% pullback rather than selling the close, generated a profit on the next bar. Again, this is, we see 136 trades, win rate of 49%, and average R of 0.17. So entirely unoptimized. But the reason for using something like this is to go through and identify places where you might be generating signals, and then to focus on the nuances surrounding the way those signals arise. So we can go back into the settings again and look at some of the other options we have here. So as we see, we're now on big breakout without follow through. So that was this bar here. Currently, it's the stop is just below the bar. So if we use a measured move of the Z bar, we end up with a negative. It goes from a positive expectancy system to a negative expectancy. And now we need to perhaps think about why that would be. I don't know if anyone has any ideas, but if you do, drop them in the comments and we'll discuss them. Right. Well, if we end up with some comments, I'll come back to them. So the reason why, and this is a good example of how the different signals this code generates should be valued differently. If you have a big breakout and the market is getting to a 50% measured move against that big breakout, then typically that is going to be a failed breakout. It's often associated with a vacuum test and going to be a failed trade. So as we see here, those placing a stop 50% measured move, which is what this stop location of 2 represents. It's a 50% measured move of the signal bar or the signal bar pair. So that was here, 50% measured move is down here, and this bar hit it. Now, there would be ways to mitigate that. You can do a time stop here. If you add a time stop, it doesn't have a substantial effect on it, but the overall profitability of the system, that trade became a winning trade. But overall profitability doesn't do much for it. What we can see, there are a few other filters which I've added here, and this is by no means exhaustive. There's lots of things that every student in Systems Academy will test. So this is a filter that does not take trades in late high time frame breakouts. And so what does that mean? That means that when you have more than 6 trending lows or highs, so bear highs or bull lows without any lower lows or higher highs. Typically, those are breakouts on higher time frames, and so this filter just doesn't enter if the breakout occurs in those late conditions. And here it doesn't enter in late trends. For Z bars, that has a negative effect, but if you check it for just regular breakout and follow through, it actually has a positive effect on the system. So again, the signals behave quite differently, and you can develop entire systems around the different signals that this code gives you the opportunity to examine. So perhaps one of the most interesting aspects of this is if you scale in. And so scaling in here, this is if so in order to have this set, the stop location has to be at 1, because what the code does is it looks at how the uh, uh, scale level 1, yeah, and then if we go to 2, all right. So if we have scaling level 1, then what it's going to do is when the bar gets to below the initial stop location, it will take an average of the price of at the entry and the original stop location here, and then move the stop to one measured move below, with the intention of getting out break even on a return to the signal bars, the signal bar low. So basically, it's or actually the average of those prices. So trying to get out break even on the trade, and here, then if you do this, this gives you the option of scaling in twice. And if you then you go in and change some of your other parameters for Z bars, it often has a positive effect to limit the amount of time since signal and entry. So you can go from a losing system, and then once scaling in and optimizing for time in trade and time since signal, you can go to positive expectancy with an average R of about half an R. Again, this is not to design an automated system around. This would not work as an automated system by any stretch of the imagination. But as a tool for focusing student effort, it can be very useful because it helps uh, students approach the nuances surrounding setups in very useful ways. So as we see here, this is a big breakout bar. It got follow through, but we're not looking at the follow through bars. We're looking only at the 50% of this bar. 66 pulls back and gets a entry at that 50%. And so this doesn't actually require any scaling in. This bar is entering at 50% of this bar and getting out again at the original target location, which is the bar low there. Let's see if we can find an example of scaling in. Wait for this to load. No trades there. Oh, so this one scaled in. So this was a big breakout bar. If you were trading this manually, unlikely that you would buy a pullback here simply because you have 3 legs up. So if you're leg counting, that's just probably not a candidate for it. But again, this is a teaching tool. So we can see here this code considered or added to the position here and took an average of that and this price, as well as so it took one entry here another entry here, and now the average is the average of those 3 entry locations. And here it got out break even on that position. And then this trade here, if we look at how many bars do we have since entry? Oh, sorry. I apologize. It was not. So this actually does not, if we, let's give it a little bit more here. Hmm. All right. So that's where you'd be exiting here on this position. So the average entry price would have been triggered there. And so this is an example of giving a little bit more space on the entry signals and the time in the trade. However, for trading big bars, it's typically not advisable to stay in the trades that long. So here we can see again, here's a big bar entry at 50% of this bar, and then out here on this bar, 50% entry here, and then out here again at the lows. Um, so again, this is a teaching tool, and one of the things that I like to do when preparing for different uh, sections of the system design process is to develop these kinds of um, you know, teaching um, mechanisms that can quickly demonstrate a point that is somewhat or can be difficult to either accept or test and validate quickly. I would never, again, this is not a way to develop an actual system to go in here and start just plugging away and trying to optimize for these numbers, because that's never going to give you the most efficient way of actually managing the positions. And one thing that we can see if we turn off here the scaling in, the expectancy of the system goes down, or the signals goes down substantially. And this is because what you're removing is functionally removing trade management. So if anything, I would take away from this discussion that trade management is almost always going to be more important than the signals your system generates. So if we don't have any questions, I wanted to keep it quick this evening. Just share some ideas about system design and ways of thinking about your process, and give you some tools to think about. If anyone wants to try their hand at coding something similar to this, I'd be happy to answer any questions if you drop them in the comments. And I'll talk to you all soon. Next time, we'll probably have Brad here and dig into some charts and talk more about how we are progressing in SA2 and what the students are um, or how they are engaging with the material, and the ways that we're uh, uh, determining or directing that process. So, welcome any comments, and looking forward to hearing from you all soon. Have a great evening. That's actually, I just got a question in here real quick, which we can talk about before I go. Armando asks what's the most important metrics are when assessing system performance. SQN is the easiest way of determining system performance is the system quality number. And while there are nuances that you can um, disentangle from it, it's the fastest way of really understanding what to expect from systems. So that's something that we use, as our kind of our first stop when assessing back test and whether or not someone should move into forward testing of a system. All right. Well, I will talk to you all soon, and have a great evening.